Question 36. A balloon having a capacity of 10,000 meter cube is filled with helium at 20 degrees centigrade and 1 atmosphere pressure. If the balloon is loaded with 80% of the load that it can lift at ground level, at what height will the balloon come to rest? Assume that the volume of the balloon is constant. The atmosphere is isothermal, 20 degrees centigrade. The molecular weight of air is 28.8 and the ground level pressure is 1 atmosphere. The mass of the balloon is 1.3 into 10 to the power 6 gram. First of all, applying the formula, PV is equal to nRT. N is W by M. Where W is the weight, M is the molecular weight if it is a molecule, or atomic weight if it is an atom. So PV is equal to W by M R T. P is equal to W into R into T divided by M into V. Now W by V, that is weight by volume, is density. So P is equal to D into R into T divided by M. Now if P is the pressure at a height h, then D is the density at height h. And similarly, if P0 is the pressure at the ground level, then P0 is equal to D0 into R into T divided by M, where D0 is the density at the ground level. Let this be equation 1 and this equation 2. Dividing equation 1 by equation 2, we get P by P0 is equal to D by D0. So this is one equation. Again, from PV is equal to nRT, N will be equal to PV by RT. अब N क्या होता है? N होता है W by M and this is equal to PV by RT. So W कितना हो गया? W will be equal to M into PV by RT. Applying this formula, we can find out the weight of helium. So weight of helium or mass of helium will be equal to molecular weight of helium into PV divided by RT. So molecular weight of helium की वैल्यू कितनी है? Molecular weight of helium है 4 into pressure है 1 atmosphere into volume is 10,000 meter cube. So we can write it as 10 to the power 4 meter cube into 1000. So volume will be changed into liters divided by R. R is 0.0821 liters atmosphere per Kelvin per mole into टेम्परेचर कितना हो जाएगा? टेम्परेचर हो जाएगा 293 केल्विन. सॉल्विंग, मास ऑफ हीलियम विल बी इक्वल टू 1.663 into 10 to the power 6 grams. Similarly, mass of air will be equal to molecular mass of air, that is 28.8 grams per mole into pressure, that is 1 atmosphere into volume. Volume in liters will be, now volume of air displaced will be same as the volume of the balloon. Now in this case we are neglecting the volume of the load. So volume of the air will be same as the volume of the air displaced by the balloon, or it will be equal to the volume of the balloon. So that is equal to 10 to the power 4 into 1000 liters divided by 0.0821 into 293. Solving this, mass of the air is 1.1972 into 10 to the power 7 grams. Mass of displaced air at height h will be equal to mass of balloon plus, at height h the mass of load is 80% of the mass of load at ground level. So it will be 0.80 into mass of load at ground level plus mass of helium. This can also be written as density at height h into volume. Similarly, mass of displaced air at height h will be equal to mass of balloon plus mass of load plus mass of helium, and this is equal to density at ground level into volume. Let this be equation 3 and this equation 4. Now mass of displaced air at ground level we have already calculated as 1.1972 into 10 to the power 7. Mass of balloon is given in the question as 1.3 into 10 to the power 6 gram. Mass of helium we have calculated as 1.663 into 10 to the power 6 gram. So from equation 4, mass of load will be equal to mass of air minus mass of balloon plus mass of helium. So this will be equal to 1.1972 into 10 to the power 7 minus bracket में 1.3 into 10 to the power 6 plus 1.663 into 10 to the power 6, and this is equal to 9.01 into 10 to the power 6 gram. ये हो गया mass of load at ground level. And dividing equation 3 by equation 4, we get the value for d by d0, which is equal to mass of balloon plus mass of helium, that is 2.963 into 10 to the power 6 plus 0.80 into mass of load at ground level, that is 9.01 into 10 to the power 6 divided by d0 की वैल्यू हो जाएगी mass of balloon plus mass of helium, that is 2.963 into 10 to the power 6 plus mass of load at ground level. Mass of load at ground level is 9.01 into 10 to the power 6. Solving d by d0 is equal to 0.85. And we also know that d by d0 is also equal to p by p0. Now, applying the formula, log p by p0 is equal to minus mgh by rt. We can find out the height. Log p by p0 मतलब हो गया log 0.85 is equal to minus m हो गया molecular weight of air, which is 28.8 gram per mole, और इसको kgs में convert कर देंगे तो it will become 28.8 into 10 to the power minus 3 kg into g. Value of g will be 9.8 into h divided by r into t. R will be 8.314 joules per Kelvin per mole into temperature. Temperature will be 293. Solving, the value of h will be equal to 1.402 into 10 to the power 3 meter. So this is the answer.